Good morning, everybody. My name is Mrs. Lombard, and I am a geography teacher from Welkom. Welcome to the program. I really hope you enjoy today's lesson. It's going to be on drainage basins, and as you know, that is the one thing that is also important in the practicals. So please pay attention and let's see if we can get this done and dusted. On the screen, you will see the introduction. It says drainage basins, and there is an example of a drainage basin that I got from the internet. That is just one of many, many examples. Remember, a drainage basin is a very, very huge area. So if you keep this in mind, you will be able to identify the features. Remember, guys, a drainage basin is something that can cover thousands, hundreds of kilometers. If you look at a great river like the Amazon, you will know that it is in South America and that it covers tens and thousands of kilometers, as well as the Nile River. The features that you will have to remember and be aware of when you have finished with the drainage basin coverage is the drainage basin itself. What is a river system? What is a tributary? What are the interfluves? The watershed, the source of the river, the mouth of the river, and the confluence. Right, let's tackle them. First of all, what is a drainage basin? Guys, very, very important. Do not mix up the definition of a drainage basin with the definition of a river system. You will see that they differ. A drainage basin is the total area drained by a river and all its tributaries. Now, if you look at the picture, you will see that the drainage basin are the dotted lines and everything in between. Remember, it is an area. So it covers the whole area in between the dotted lines. There you will see an example of phase 2 of the Lesotho Highlands Water Project and its drainage basin. You will see it covers a huge area. There is an example of drainage in South Africa. And this one, you will see all the rivers in South Africa and their drainage basins. Now, if we look at this picture, you will clearly identify the Limpopo River, the Orange River, and the Vaal River. You will see those are the big or the huge or the thick blue lines. Also, you will be able to identify that the eastern part of the country has more rivers and therefore more drainage basins than the western part. And by this time, you guys know that is because of the higher rainfall in the eastern part of the country than in the western parts. Remember, we said a drainage basin is the total area covered by a river and its tributaries. Now we come to a river system. And do you remember I told you, do not mix up the two definitions. The river system, guys, is the main stream and all the tributaries to the main stream. So in the picture on the screens, you will see that that is everything in blue. Now, let's go back to drainage basin. If you look at this picture, you will see that the drainage basin is everything in between the yellow lines, whereas the river system is only the parts that are in blue. So, it's only the water parts. With other words, guys, the drainage basin consists of the tributaries, the main river, the interfluves, the watershed, whereas the river system only contains the water parts, so the main stream and the tributaries. Now we come to the interfluves. Remember, that is part of the drainage basin. Interfluves are the higher lying areas between the different individual tributaries. Do not mix up the interfluve or the interfluve with the mainstream. Okay, so those are the higher lying areas between the different the individual tributaries. Do not mix it up with the watershed. Okay, you will see in between those different little streams, there are higher lying ground areas. So they only separate the different individual tributaries. Now we come to the watershed. The watershed is an area or a reach of land that separates different drainage basins from one another. Okay, if we go back to the picture of the drainage basins in South Africa, you will remember that I told you that the eastern part of the country has more drainage basins because of the higher rainfall. Remember, guys, that the main watershed there is the Drakensberg. We also call it the escarpment. And that separates one drainage basin from another drainage basin. Meaning that the total drainage basin of one river, say for instance the Vaal River, is divided by the total drainage basin of another river, which can be the Orange River, by a watershed. It sheds the water into two different sides or two different parts. Now we come to the source and the mouth, and this I'm sure you guys know what I'm talking about. The source is the place where a river starts, and this is usually in higher lying areas or in areas with a higher rainfall. The mouth of the river is where the river flows into the sea. I'm sure you guys know what those two are. Right, now when we look at this picture, you will see I'm going to give you some time to see if you can identify the different features of a drainage basin. First of all, can you identify the drainage basin itself? Remember, the definition is the total area drained by a river and its tributaries, which has to be between the lines of the watershed. So look at that picture. Are you guys able to identify the drainage basin? Then, are you able to identify the river system? Remember, the river system is the main river and all the tributaries. Are you able to identify the tributaries? Remember, those are all the small rivers that flows into each other to form the main stream. Are you able to identify the interfluves? Interfluves, higher lying areas between the smaller parts, in other words, between the tributaries. Can you identify the watershed? Remember, it's the higher lying area separating two different drainage basins from one another. The source, usually in higher lying areas, the mouth, which is usually the sea, and then confluence. Guys, the confluence is where the tributaries enter the main stream. And by looking at the confluence, you will be able to determine in the practical to which side or to what direction the river is flowing. Remember, it must flow into the river with an angle. It can't flow upstream. So an interfluve has to flow into, or a tributary has to flow into a river. It has to follow the contour lines. So it's following the contour lines from a higher lying area to a lower lying area. Let us recap. Remember, you must be able to identify the drainage basin, the river system, the tributary and the interfluve, the watershed, the source, the mouth, and the confluence. Please feel free, if you do have any questions, to post them now so that I can answer them later on for you. The next part. And this is usually where the math and we all get disconticulated. Guys, calculating stream orders are not that difficult. Remember, I don't think that they will ask you to calculate a stream order for up to, say, 18 or 20. Because, I mean, that would be ridiculous, having to count all those streams and then getting to an answer. It would take up too much of your exam time. So, let's say you will be able to do it up until order 10 it's fine, even if it goes that high. Right. Very important is, first of all, identify the streams that flow outward, inwards. Okay, so we have to see where this stream starts, where this river starts. Where does it get its water from very first? Okay, so when it rains, the water will divide by the watershed from one drainage basin to the other. Okay, so the very first streams that flow is going to be number 1. So if you look on the picture, you will see. Are you able to identify the watershed? It says watershed or boundary. Okay, so you will see those, as we just learned, is the higher lying areas. All right, so the higher lying areas is going to provide the very first water. Water is going downwards. The very first stream is therefore order 1. Okay, look on the right-hand side of that picture. Now we have 2 order 1 streams flowing together. Do you see, as soon as it flows together at the confluence, we see that the streams widen, or the resulting stream is wider. Why? It contains more water. More water it contains, the thicker the stream becomes, the more energy it has. And therefore, stream 1 and stream 1 compared has the same amount of water. When they flow together, they create stream order 2. Okay, look at the bottom. There are also 2 streams of order 1 flowing together, creating stream 2. The same at the bottom. 2 stream 1s flowing together, creating stream number 2. So the more water you get, the higher the number of the order become. Okay, now we continue. As soon as two order streams flow together, we get an order 3 stream. And by that, we can calculate up to the end that this is an order 4. Now, a question that usually derives from this is they ask, how do I write it in the exam? You only write. When they ask you, what is the order of the stream, say for instance at X, Y, or Z, you only write down order 1, 2, 3, or 4. Okay. Guys, just to draw your attention to something, look at the middle of that stream. Starting from the right-hand side, we have 2 order 1s flowing together, creating order 2. Then another order 2 joins in, and it becomes order 3. Now have a look. We have order 3 plus order 1 plus order 1. Can you guys see that it stays order 3 all the way? Up to the point where 2 order 3s flow together to create an order 4. Remember, you cannot calculate with unevens. So if I say 3 plus 4, that won't work. We must say 3 plus 3 equals a 4. 4 plus 4 equals a 5. As I said, I don't think that they will give you a very high order because that would take up too much of your time. Let's have a look at another example. You will see we've got the blue ones. They are the thin ones flowing together. 2 order 1 streams creating an order 2. 2 order 2 streams creating an order 3. Now, just for interest's sake, if I have to ask you in what direction that river is flowing, that would be southeast. How do I know it? Look at the angle in which those tributaries join the main stream. Can you see? They are flowing from a higher lying area to a lower lying area, therefore creating that angle. If that had to change around and flow upward, then that stream would have flown to the northwest. Okay, there's another example of stream order classification for you. Remember, start numbering from the outside, moving to the mainstream. And as you can see there, the very last question that they asked is, what was the order of the stream at A and B? And that was 4 in both cases. So, do you see? It doesn't matter how wide the stream or the drainage pattern is, or how great a ground cover it covers, it can still lead up to the same order number. Okay, remember guys that on a topographical map, you will also have to calculate the stream orders. Here is an example. If you look at those stream orders, you will see that there are a lot of stream order 1s. Them flowing together will create a stream order 2, and then in the end, the highest stream order in this one will be a 4. Now, the difference between this is, and the previous ones are, these stream orders are not identifiable in periods of drought. Now, this can also be a question. Which stream orders will dry up first in a drought season? Stream order 1, because remember, those are the smallest streams, and then those are the ones with less water. So in a drought season, remember, it will not rain, so stream order 1 will disappear. Therefore, everything that is stream order 2 will then become 1. The 3 will then become 2. And the whole stream order of that whole system will then become less. Okay, now we come to stream density. Remember guys, stream orders are 1, 2, 3, 4, 5. You calculate them from working outwards, inward, and then you get a 1 and a 1 become a 2, a 2 and a 2 become a 3. Stream density, guys, is the length of the streams in comparison to the area in which it is found. Okay, now in all my years, and I've been a geography teacher for 16 years now, they have never asked in any question paper the question on calculating the stream density. They will ask you how to calculate it, and that is the total length of the stream in kilometer divided by the area of the drainage basin. If they do give you the total length of the stream and they do give you the area in kilometers, then guys, you will be able to calculate it. But I don't think that they will ever ask you to go and measure each of those streams, calculate it together, and then do the division and then get the answer. So you don't have to worry about that. Whenever they do ask a question like this, they will either ask you how to calculate it, and then you must write down the formula, total length of stream in kilometer, divide by area of the drainage basin, into square kilometer, or they will give you the total length of the stream and the area of drainage, and then you will have to calculate it. So please don't worry about taking along pieces of string and having to calculate the length of the river. Okay, if we look at those two pictures on the screen, you will see that the one on the left-hand side has a denser drainage than the one on the right-hand side. Now, remember guys, drainage is coverage, meaning the water that you can see is the water that you have to calculate. So everything that is groundwater, with other words, everything that infiltrates into the ground is not calculated. So if you look at that picture, it's got the same area. So it's the same amount of ground cover. But the stream on the right-hand side is far less than the one on the left-hand side. And therefore, we say that the drainage is less. The stream density is less. If you do have any questions up to so far, please post them now so that I can help you with them. Okay, very important for the practicals guy is drainage patterns. Now, remember a drainage pattern is according to ground cover. So when we look at a drainage basin, we will be able to identify certain patterns of drainage, and you must be able to identify the different patterns on a topographical map. You must look at the pattern that the water forms when it flows on the ground, and then you identify the drainage pattern and you answer all the questions according to the different patterns. Now, please remember two things here. As you will remember, the paper that we just wrote in this June exam, they did ask you the drainage pattern, and then they asked you, very important, on what type of rock or on what type of underlying structure will you find that specific drainage basin or that specific drainage pattern. Guys, this is very important. Usually, when you study, you look at the picture, you say, oh, okay, I can identify this. This is the tree-like pattern, so this is dendritic. Okay. But remember, they will ask you questions on the underlying rock structure. So you will have to study those underlying rock structures that you find that drainage basin upon. Okay, let's look at the very first one, the dendritic pattern. There's an example for you. Remember, it looks like a tree, but you are not allowed to write the tree-like pattern. The fact that it looks like a tree is only a way to make you remember that it is the dendritic pattern. So please don't write tree-like pattern as it will not be marked correctly. Okay, now guys, the dendritic pattern is the most common drainage pattern. It is found in areas with the same ground cover. Example, everywhere as hard or as soft. So there is no alternating hard or soft rock. We've got just hard rock or just soft rock, and then it is commonly found in massive igneous rock or sedimentary layers. Can everybody identify the tree-like? With other words, the dendritic pattern. Now we come to the rectangular pattern. Look at the picture. It is found on igneous rock. Those igneous rocks have cracks and seams, and the streams on top of those rectangles follow them to where they meet. Now, this is an example. Guys, this is how the rectangular pattern looks. Can you see how it looks under the ground, underneath the earth's surface? It follows the streams, or the streams follow the patterns. Do you understand now how we get that blue pattern on top? Because it follows the pattern from underneath. Next one is the trellis pattern. Now the trellis, guys, is a very fine pattern. Remember, do not get confused with the trellis pattern compared to the rectangular. The main difference is the trellis are those are finer streams. They are a bit shorter, but they are finer. It is found in inclined rock with differing hard and soft rock, or on parallel crease mountains. The shorter streams form on the softer rock, which are eroded faster. I want you guys to compare this trellis pattern with the rectangular one. Do you see? Trellis are far more finer than the rectangular. Now we come to the radial pattern. The radial pattern is very easy because it flows outward from a higher point, and it looks like the spokes of a bicycle. Do you see there? Underneath is a bicycle frame and the spokes of the wheel. And you will see it is the same pattern that is on the right-hand side. It flows from a higher lying area outward. As you can see, look at the direction in which the water flows. It flows outward. If I compare that with the centripetal pattern, you will see that that is just the opposite. Those streams flow to a lower point, outward from higher points. Remember, the radial pattern from the higher point downwards to outwards and downwards, and then the centripetal pattern from higher lying area downwards to a marsh or a vlei. Okay, now we come to the deranged pattern. Now guys, this is very easy. You will see the deranged pattern. It has no definite pattern whatsoever. If you compare that picture to the previous ones, you will see that the deranged pattern is one that is not easily identifiable because there is no feature in it. It can follow any stream, any pattern. Okay, it goes to different points of flow, and as you can see, it flows into different marshes, different streams, not flowing in a certain pattern at all, like the rectangular or the trellis or the dendritic pattern. Now we come to a new one that was added to the caps, and that is the parallel pattern. Now, as soon as you see that, what do you think? You think trellis. Okay, and you are correct. It is sometimes part of the trellis pattern. The streams flow parallel into each other, and then it follows the gradient of the ground, and it flows into a bigger river or a lake. And therefore, it can be found at the foot of the Drakensberg. Do you see? It does follow the trellis pattern up to a point where everything flows into a lake or a big river. That is the difference. The parallel pattern flows into a river or a lake, whereas the trellis pattern is a stream that flows eventually into the sea. Okay, we are going to write a small test now. Grab a pen and paper, and I am going to ask you to identify the following stream patterns. Number A, what do you think that is? Number B, number C, look at where the arrows are pointing. Number D, number E, number F. So, how did it go? Let's compare your answers. A was the dendritic pattern, B was the trellis, C was the radial pattern, D was the rectangular pattern, E was the centripetal pattern, and F is the deranged pattern. How did it go, guys? If it didn't go so well, then you should go back to the books or ask me questions if you are not sure. Please feel free to post those questions now. Right, now we come to stream channels. There are two flow patterns. Guys, we get a turbulent flow and a laminar flow. Right, now I really want to stress this out. Guys, laminar flow doesn't necessarily mean that it is moving slowly. And turbulent flow doesn't necessarily mean that it is flowing faster than the laminar flow. Underneath the laminar flow, there are pockets of water moving very, very fast. Okay? And you will see, when you look at turbulent and laminar flow, you will rather enter a laminar river than a turbulent one. But it can be equally dangerous because the pockets of water in the laminar flow are flowing very fast underneath where you cannot see. Okay, there is an example of the turbulent flow. You will see it is a restless flow with a lot of erosion taking place, and the turbulent river has an uneven river bed. The uneven river bed causes friction and a slower movement of water. And because there is a lot of erosion, the water takes on a brownish color, sometimes with foam, and it looks like the water boiling in a pot. Now we come to laminar flow. Do you see? I'd rather enter a lake or a stream or a river where the water looks like that. But be careful. The laminar flow is a more peaceful flow. There are less erosion taking place, and the laminar river has an even riverbed. The even riverbed causes a slower movement of water, And there is a comparison. Now, do you see the movement of the water particles in the turbulent flow? It is moving anyway, every way, just as it wants to, therefore creating the brownish color and creating the foam. Whereas the laminar flow, guys, do you see the pockets of water moving underneath? Can you see that can still be very fast? Have you ever heard of a slipstream? Have you ever heard of someone just swimming and then the stream underneath took it and then they drowned? Guys, look at that laminar flow. That is something that can confuse you. Remember, the water pockets underneath can flow very fast and you won't be able to see it. If you have a look at this, you will see the ones at the bottom, the water particles flowing at the bottom of the screen, those are laminar flow, and then do you see as soon as it goes over that rapid, it turns into turbulent flow. Another example, do you see laminar flow on the left and then turbulent flow on the right? If you do have any questions about these water flow patterns, please post them now so that I can help you later on. We now move on to the types of stream flow. Okay, now this is something that they can ask you in the practical. So guys, please make sure that you do understand it. I know that it is not very easy to demonstrate, as rivers and flow in different parts of the country, and rivers, it goes through different stages. But let's have a look and see if we can identify them. Right, the very first one is the permanent stream or the permanent river. Okay, now guys, in a permanent river, the height of the water almost never changes. Meaning, if I go to, say for instance, the Tugela River during the winter season, it will be almost the same height as it is in the summer season. So the river has a constant water flow throughout the year. It doesn't change by season. It doesn't change whether it rains a lot or not. It stays the same throughout the year. And you will see an example, as I told you, is the Tugela River in South Africa. That is a river that we get in KwaZulu-Natal. Then we come to periodic rivers. Periodic rivers are rivers that run dry on occasion, usually located in arid climates where evaporation is greater than precipitation. And examples of that are the Limpopo, the Vaal, and the Vals River. All right, so the periodic river, guys, will change according to season. Let's say, for instance, we have summer season in the Free State. Then these rivers that are periodic rivers in the Free State, like the Vaal River and the Vals River and the Sand River, those rivers will then have water. And depending on how much it has rained, they will have either a lot or a little water, but they will have water. But in the winter season, it is possible that those rivers can run dry, or at least parts of those rivers can run dry. Therefore, which stream order do you think will dry up very first? Stream order 1, then stream order 2. And if stream order 1 dries up, stream order 2 will become 1, 3 will become 2, and so forth. Therefore, the total stream order of a periodic river will decrease. Do you guys still remember that? So let's just have a look. What is the difference between a permanent and a periodic river? A permanent river is a river where the height of the water almost never changes. Not even depending on the season, it's always the same amount of water, like the Amazon, the Nile, the Tugela River. A periodic river is a river that runs dry on occasion, usually located in an arid climate, guys, meaning that according to season, the number of water or the amount of water in that river will decrease or increase. Next, we get the episodic river. Now, guys, an episodic river is something that we do not get commonly in South Africa, but we if you remember the Laingsburg floods, where the Buffels River dried up for 100 years, or that very part of the Buffels River dried up for almost 100 years, people didn't know that they were building in the riverbed. And then for the first time in 100 years, that Buffels River came down with a lot of water. That is the main reason why Laingsburg had that huge flood in 1988. If you still drive through the town today, you will see in the middle of the town there is a little pole with a flag on it where it shows you this is how high the water went in the 1988 flood. So, and you won't be able to believe, guys, that the water of that small river down in the valley came up to that height. And that is because it was an episodic river. Now, an episodic river rarely occurs. It is formed from the runoff of channels in very dry regions. Okay, so an example can be the Nile River. As I told you, an example can also be the Buffels River in South Africa, although we do not have many episodic rivers in South Africa. Now we come to the exotic river. Remember, the exotic river is something that is out of the ordinary. Okay, why? Because those are rivers that flow through arid or through desert regions, and it is a huge river. It has a lot of water. Another example of that can also be the Nile River. Guys, it flows through the desert, okay, but it has a lot of water in it. Parts of the Nile is an episodic river, that is true, but a good example is the Awop and the Nosop rivers. Now, those are in Namibia, and you know that the largest part of Namibia is just desert, so the Awop and the Nosop rivers are huge rivers running through a dry land. If you do have any questions, please feel free to post them now. Right, let's recap everything that we did so far. Very important, guys. Remember, if you do have any questions, please ask them to me now so that I can try to answer you to the best of my ability. Right, what is a drainage basin? A drainage basin has very important features that we have to remember. The river system, the tributary, the interfluve, the watershed, the source, the mouth, and the confluence. Remember, you must be able to identify all those features on a topographical map or on a picture that they give to you during the exam. Right, let's recap. What is a drainage basin? Remember, it is the area that is drained by a river and its tributaries. Right, so the drainage basin in that picture is from watershed to watershed. Okay, so from dotted line to dotted line. The whole area in between, meaning the river, the source, the mouth, the interfluve, the higher lying areas, everything in between is the drainage basin. Whereas the river system is only the tributaries and the main stream. With other words, only the water parts is the river system. Right. Interfluves, remember, you have to look at the difference between an interfluve and a watershed. Okay. An interfluve, those are the higher lying areas between the different individual tributaries. Do not confuse it with the watershed. If you look at that picture, the watershed is the dotted line, whereas the interfluve, those are the higher lying areas between those little streams. Okay, the watershed is the area or the reach of land that separates the different drainage basins from one another. As you can see there, remember, it has to make water go from one side to the other. The source is the place where the river starts, which is usually in the high-lying areas, and the mouth is where the river flows into the sea. Let's just make sure about the confluence. The confluence are where those small tributaries flow into the main stream. Okay, let's come to stream orders. Remember, start numbering from the outside inwards. Start numbering from 1. There will always be more number 1 orders than any other order. So, in the dry season, number 1s will dry up, and then your order will decline according to how dry it is. Okay, a 1 and a 1 becomes a 2. A 2 and a 2 becomes a 3. Remember, 2 and 3 does not become 4. We have to have stream order 3 joining stream order 3 to become stream order 4. Right, stream density. How do we calculate it? We take the total length of the stream in kilometer and we divide it by the area of the drainage basin in kilometer square. I told you, you won't be able to calculate it because it will take you the whole time that you are there writing exam, all 3 hours to calculate it. They will have to give you the total length and the area. And you will also have to be able to provide the formula. That is total length of the stream divided by area of the drainage basin. You will have to be able to compare, is it a dense or a less dense drainage density? The one on the left is the denser one than the one on the right. Okay, very, very important, guys, drainage patterns. Do not forget that you have to study the underlying rock structure. Very important. You look at the features and then you identify it according to the pattern. That one is dendritic. Do not write the tree-like pattern. That is only a way for us to remember it by. And it is found in massive igneous rock or sedimentary rock that is equal in hardness or softness. The rectangular pattern is also found in igneous rock, but those rock has cracks and seams, and then when the water starts flowing in that river, it follows those cracks and seams to where they meet. The trellis pattern, that is the fine one, found in inclined rock with differing hard and soft rock or parallel crease mountains. They form on softer rock which are eroded faster. Do not confuse it with a rectangular pattern. Radial pattern flows outwards from a higher lying point, and the centripetal pattern flows inward from a higher lying point. We also get the deranged one. That is where there are different points of flow and no identifiable pattern. Guys, with other words, there are a lot of marshes, a lot of lakes that this stream flows into. Then we get the parallel pattern. The parallel pattern is sometimes part of the trellis pattern. Remember, the main difference there is that the parallel pattern flows into a bigger river or a lake, like at the foot of the Drakensberg. Okay, have a look at your answers again. A had to be dendritic, B trellis, C radial, D rectangular, E centripetal, and F deranged. Right, we come to turbulent and laminar flow. Remember, guys, you will have to be able to draw differences or conclusions between turbulent and laminar flow. So, if they ask you the amount of erosion, that will be greater in turbulent than in laminar flow. If they ask you the speed of the water, that will be greater in turbulent than in laminar flow. Okay, so you will just have to compare the two to each other. Let's look at turbulent flow again. There's a lot of erosion taking place. The turbulent river has an uneven riverbed. The uneven riverbed causes friction and a slower movement of water, and it looks like the water boiling in a pot. And then the laminar flow is a peaceful flow. There are less erosion taking place. It has an even riverbed, and therefore, guys, it is a slower movement of water, or you can also say a faster movement of water depending on how the riverbed looks and how the water goes down. Okay, there is the comparison between the two. And if you have to identify it, you can have a look there. Look more peaceful and turbulent. Okay, the very last thing that we did is the types of stream flow. We get permanent rivers, periodic rivers, episodic rivers, and exotic rivers. Main thing is the permanent river is the one who always has water, where the water level almost never changes. The periodic river is the one that only flows in season. The episodic river is the one that is formed only when a hard rainfall occurs, like the Buffels River, and then the exotic river is the one that flows through an arid or a dry region. How they can ask you this is during the practicals, they can ask you, say for instance, you are studying an example of the Orange River, say for instance like Uppington, then they can ask you, what kind of river is the Orange River? How does it flow? In what kind of region? Why do you say that it is an exotic river? All right. It is now almost 3 minutes before we have to go to break. If you guys have any questions, please post them now so that I can answer it to you. Please feel free. I'm here to help you. Hello guys, we are back. There weren't any questions up to now, but if you do have a question, please post it during the break. We are going to have a 10-minute break now. We will be back at 9 o'clock, and then I will answer them to you. Please, guys, if you're not sure about anything, post them. Otherwise, I will see you at 9 o'clock. Welcome back, guys. I hope you enjoyed the break. During the break, there were 2 questions that I'm going to ask that I'm going to explain quickly. The very first one was, please repeat the centripetal pattern from Ipatileng. All right, let's go back quickly. Guys, I'm going to do the radial and the centripetal pattern because that will explain and make it easier for you to understand. Okay, if we look at the radial pattern, remember that is the pattern flowing outwards from a higher lying area. So we've got a higher point in the middle and it's flowing downward, outwards. With the centripetal pattern, it is just the other way around. All right, we have a higher lying area around and it is flowing downward to the center. So it's either flowing into a lake or a dam or a marsh. So it's going from the outside is higher. It's going downward, 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 down to the bottom where there is a lower lying area. Okay, so those two are just the opposite. One is from the higher lying area outward, that is the radial pattern, and the other one is from the higher lying area downward, that is the centripetal pattern. Then there was also a question about, during examination, is there a possibility that we could be asked to identify the underlying rock of the 2 stream flows? Now, I presume that is the turbulent and the laminar flow. You won't be asked that question. The only place where you will be asked about the underlying rock structure is the drainage patterns, meaning dendritic or the parallel or one of those. Right. Guys, then there is another question. How does each of the 4 types of rivers shown on a topographic map? Right. Let's go quickly. Right. That is where I told you that it is actually very hard. This question is very hard. You won't be able to see on a topographic map if a river is permanent or periodic, except for when they show you that the river has run dry. Okay, do you remember we did a part on braided streams and on meandering streams? Right, now guys, if you look at those 4 types of stream flow, you will see the permanent stream will not have a lot of braided streams. It will not have meandering paths. Why? Because the river also always has almost the same amount of water in it. With other words, the river always flows equally as fast or as slow throughout the year. Okay, the periodic river. That one will be shown as either marsh or vlei that is on the topographical map in the river. So if there is an indication of a marsh or a vlei in a river on a topographical map, then you know there used to be water in that river. Now it is not there anymore, or that amount of water for the river to flow is not there anymore, meaning that this river will only flow when it rains again in the rainy season. That is the periodic river. The episodic river is a dry riverbed. Okay, so there's no water flowing there, but there is a risk building in that dry riverbed. And then the exotic river is the one that has a lot of water, but it flows through a dry region. Okay, now we come to the place where I drew up some changes or some differences between the laminar and the turbulent flow during the break. I'm going to show them to you quickly. You can write it down if you want to. These are just some of the examples. Those are not all the examples. You can go to your textbooks and have a look at the difference between laminar and turbulent flow. I'm going to show you these four quickly. The laminar flow has less erosion, and the turbulent flow has more erosion. The laminar flow has an even riverbed, whereby the uneven riverbed is characteristic of the turbulent flow. The laminar flow has a faster movement of water, whereby the turbulent one has a slower movement of water. And then in the laminar flow there are less friction, whereby by the turbulent flow we have more friction. You guys can write down those differences quickly, and then I can continue up to the longitudinal and the transverse profile. If you are not finished yet, please just give me an indication by question, and then I will come back to that one when we are finished. Right, guys, let's move on to the profiles of a river. Now, the profiles of a river, there are two profiles. The one is the longitudinal profile, and the other one is the transverse or the cross profile. Very important. You have to identify the features of each of these profiles. Okay, now guys, the longitudinal profile. That is the side view of the profile from the source downward to the mouth. Do you remember? When we did the drainage patterns, I told you you have to identify the source and the mouth. The source is where the river gets its water from, and the mouth is where it goes out into the sea. Right, so guys, the longitudinal profile is very important. The side view of the river from the source to the mouth. Each and every single river in the world. Doesn't matter if it is permanent, exotic, episodic or periodic, those rivers are trying to create a graded or a concave profile. Right. Last year, this was a question. How do we know that this river, the river in the picture, was graded? The answer was because it has a concave profile. So each and every river in the world strives to be like a concave profile. Guys, there is the longitudinal profile of a river. Do you see steep gradient at the head? That is the source. And then a gentle gradient near the mouth, which is the mouth. Then you will see it has striven to be a concave profile. Now you guys know, grade 10 work, that profile will not stay like that very long, because in the sea, the earth is going to bend down, and then it's going to move up on the other side, or it is going to create that unequal feeling and it's going to have to stabilize that. So that is not going to stay very long. But as soon as you see a graded profile, then you know that this river has a concave graded profile, the longitudinal profile. Right, now we come to the transverse or the cross section. Guys, very important. If I get into a river and I cut it in half, I lift it up, that is the transverse or the cross profile. I'm telling you again, I'm getting into the river, I'm climbing into the river, cutting it up, and I'm putting it up in front of me so that I can see the transverse. With other words, I can see how it looks if I look through the river standing in it. Look at the picture. You will see we have an A, B, and C. And you can also compare it to the next one. Right. At number A, you will see that that is the top part. With other words, we are at the source now. Do you see that the V shape of that top part of the source is closed? We have very steep valleys there, and there is not a lot of water flowing there because we have not had tributaries joining this river. When we go to the number B, that is the middle part of the river, you will see that the V is more open now because water has started flowing in from the sides and it has created erosion, and therefore the sides are not as steep anymore. And then we go to C, that is the bottom part or the lower part of the river. You will see that all those sides has disappeared and it is an even open V. So if you have to compare it, it is a closed V becoming more open as it goes downward to the mouth. Right. Then, if I look at the longitudinal profile and the cross profile of a typical river, there is a comparison, and you guys will see they have done it in the upper, middle, and lower reaches of the river. Okay, let's look at the longitudinal profile. The longitudinal profile in the upper valley or in the upper reach is steep. You guys see, because that is the gradient is steep, that is where the river has its water from. That is usually in the mountains. Okay, when we go to the middle part, you will see the gradient become less. So it is not as steep anymore. And then when we go to the bottom part, you will see it is still less steep, and then it is becoming more even. Whereas if you compare that to the cross profile, you will see that the upper valley is steep, V-shaped. The middle in the reach is the channel is deeper, it's wider. We now have vertical erosion and more lateral erosion. And then in the lower reach, you will see that it is wide open. It is at the widest and the deepest. Where do we get the most water? In the lower reach. I think that was also a question during this exam. Okay, please feel free if you do have any questions to post them now. I'm just going to answer a question quickly on how do we know in what direction a river flows. Okay, let me explain that to you quickly. Right, guys? Say, for instance, that we have a river flowing and we have a tributary joining in that direction. Do you see it's flowing from the higher lying area to the lower lying area? Meaning it is moving from that higher lying area into the river to the lower lying area, meaning that this river is flowing northwards. If I take another example, let's do another one. I have flow of a river and it is joined by a tributary like that. There is the confluence. Then this river will flow in the northeasterly direction. If I have another one and I have a river flowing like this, and I have it joining at that angle, then there's the confluence. That river will be flowing south. Is everybody clear on that? Look at the angle in which the tributary joins the main stream. Right, we now come to base levels. Now guys, this is really easy work. We only get two base levels. We get the temporary one and the permanent one. Now, temporary ones are everything that store water for a short period and then let it go in, and then it lets it go. So, dams, lakes, waterfalls, those are examples of temporary base levels. The only permanent base level that we get is the sea or the ocean. Now, I am sure that you guys have seen pictures like this before in old exam papers. They give you the longitudinal profile of a river, or they give you a drainage basin. And then they ask you to identify the temporary and the permanent base levels of the river. Guys, very easy. Anything that is not the sea is a temporary base level, meaning anything like a waterfall, a dam, a lake, anything that you can store water in for a certain period of time. What I mean by that is, if we build a dam into a river, then the water will flow downward in the stream into the dam, and the water will be stored there for a time. As soon as it rains a lot and the river starts flowing more and more and more and it goes into the dam, we will open that dam and then the water will go on downward. Right? So do you see? It has only been stored there temporary. Even if it takes 50 years, that water will only be stored there temporary. That's why it's called a temporary base level. The permanent base level is only one place, and that is the sea. Now, yes, it is true. The water does go back via the water cycle. It is true. The water goes back over the land and it starts flowing again. But remember now, that is the water cycle. That is not the base level. So there's only one permanent base level, the sea. If you do have any questions about what we've just done, guys, transverse and longitudinal profile is very important. Please post them now so that I can answer them. Okay, now we come to the dreaded stream piracy. Guys, for some or other reason, you guys really struggle with this. And it is actually very easy. Let's have a look. Okay, there are certain features that you have to identify. The first one is the captor stream. Now guys, the captor stream is the one taking the water. So I am doing the stealing. I am taking the other river's water. The captured stream is the one from which the water is taken. The elbow of capture is the precise place where the water is taken, meaning, guys, that you will see it looks like the elbow of a person. The misfit stream, now this is important, that is when the river bed is wider or it is larger than the amount of water flowing in it. Now guys, this can also be true of a periodic river. A periodic river can also have a huge riverbed with a little water flowing in it. But remember, we are now at stream capture. So, the misfit stream is the one that now has less water in it than it had. And then the dry point is the place where the water used to flow. Okay, let's look at the picture. Look at the picture there, and then you will see this is a real example of Mullam Creek. You will see before there were two streams. The captured stream is the one at the top, sorry. You see it flows there, making a little angle, and then you will have the capture stream. Now, do you see? Through erosion, this capture stream moved upwards up to the captured stream. And then it took its water. So, identify the features. The wind gap is the place where the water used to flow, right next to the elbow of capture. Do you see? It looks like the elbow of a person. The wind gap is the place right next to the elbow. With other words, the water used to flow there. And now do you see the misfit stream? You will see the water is now moving in another direction, meaning that there is less water than there was before in that captured stream. And that is called a misfit stream. So there is less water than there used to be. Right, there's an example of river capture. Here's another one. You can clearly see the elbow. You can clearly see the misfit stream. There's less water in it now. Guys, please make sure, I know that during the June exam now, you had to draw those features. Make sure that you are able to draw the following. The capture stream, with other words, the one taking the water. The captured stream, that's the one from which the water was taken. The elbow of capture, meaning that is where the water was taken from. And the misfit stream, so that is where the captured stream used to flow. Now there's a little less water. And then a dry point. That is right next to the elbow of capture. Another question coming in. Question is, what is the main difference between the centripetal and the radial pattern? Right, let's explain that quickly. Guys, the main difference is the flow of water. If I have a higher lying area in the middle and the water is flowing outward from that higher lying area, then that is the radial pattern. How will I identify this on a topographical map? Do you remember? It will be an area where the contour lines are close to each other, like that. You guys know that means higher lying area. We can even go on further like this. Right? So the water will flow downward in that direction, outward. Right? So that is the radial pattern. If I do have something like a higher lying area around, and the water is flowing downward from that, and it's going to rain, then the water is going to flow downward from that higher lying area into that, and there may be a lake there. So it's flowing downward into a place, and that is the centripetal pattern. Right. So the radial pattern has a center that is higher lying and it's moving outwards. Whereas the centripetal pattern has a center that is lower lying and the water is flowing inwards. I hope that explains your question. Guys, let us recap quickly what we have done during the second half. That was the profiles of a river. Very first one is it is a longitudinal profile. Remember, always striving to take out all those temporary base levels. With other words, always causing erosion, always causing movement of water, always causing that we want this dam or this lake or this waterfall to move. We want a very concave profile. As soon as we have a concave profile in the longitudinal part of a river, or in the longitudinal profile, then we have a graded profile. The profile of the longitudinal is the side view of the river from the mouth to the source. The transverse profile, guys, is if I climb into the river, I cut it across, I lift it up. So I want to see from the one side of the river to the other side of the river. Remember, longitudinal from source to mouth. Transverse or cross profile is when I get into it and I see the one side of the river and the other side of the river. That can be divided into 3 parts, each of those. We get the upper valley, the middle reach and the lower reach, or the upper reach, the middle reach and the lower reach. Remember, the longitudinal profile is very steep in the upper reach, more flattened or less gradient in the middle reaches, and then it is almost flat in the lower reach. Whereas the transverse profile is steep, V-shaped, steep valleys, V-shaped, close V-shaped at the upper valley. Then in the middle reach, it's more open with more vertical erosion. And then in the lower reach, you will see that it is widest open and it is the deepest. When we look at deposition, guys, just make sure at the upper course, there is a lot of erosion and just a little deposition. Almost no deposition there. Then in the middle reach, we have less erosion, but a little more deposition. And then in the lower reach, we have almost no erosion and just deposition. Go have a look in your textbooks. They do explain it to you very clearly there. If you are not sure, please post the question now. When we come to base levels, those are very easy. We have temporary base levels, that is anything that is not the sea, and then the permanent is the sea level. At stream piracy, guys, make sure that you can identify the captive stream, the captured stream, the elbow of capture, and the misfit stream. Right next to the misfit stream, we have a dry point, meaning that is where the water used to flow. Right. If you do have any questions, please post them now. We do have a few minutes left in which I can answer any question about today's presentation that you would like. Guys, we are back. There were no more questions, but if you do have questions, please feel free to ask. I'll try to answer them to the best of my knowledge as possible, but for now, the session is over. Thank you very much. Please study hard. You will never ever be sorry that you studied your matric. I promise you, your matric certificate goes through life with you like your ID book. So, I wrote my matric 20 years ago. Please, guys, you will never ever be sorry. Any questions? Do post them. I will answer them. Thank you very much and good luck.